Cool. Okay, let's get started. Sweet. Wonderful. Okay, hopefully you have all your quizzes in. I should have those graded pretty soon. Um, we've been talking about quadratics, so I suppose let's talk more about them. Now we've been doing everything besides graphing, and that's what we're doing today. So we are graphing quadratic equations. Okay. Well, first of all, say you are given a function to graph. And as we know, maybe a function looks like this, y equals x squared. It can also be given as this, f of x equals x squared. This is just saying there's a function of x. And for both of these, all this means is the output of the function, either you're calling it y or f of x, the output is x squared. So it can be notated either way. There's no reason to I think you guys have seen this notation before. So, say we are given a function and we have no clue what it looks like. So, what do you do? Well, one good thing to do, well, probably the only thing you can do if you don't know what it looks like, is to start and construct a table. So let me just draw some axes here. I'm not sure what this graph looks like. So, when you graph an equation, what's happening is you're graphing all of the ordered pairs that satisfy the equation. So if I make a table of x and y values, I can find ordered pairs that satisfy this equation just by picking any old random x values, plugging them in, get the y value, and then I can plot the ordered pairs. And so there's no strategic way to choose these or anything, but maybe usually x equals 0 is a good one. So y equals x squared, y equals 0 squared, so y will be 0. Let me also choose x equals positive 1, so y equals x squared, y equals 1 squared, so y is 1. Let me do x is positive 2, y equals x squared, so y equals 2 squared, y is 4, right? So, I mean, we're squaring these numbers, right? 0 squared is 0, 1 squared is 1, and 2 squared is 4. Here are three ordered pairs for this function. They satisfy the function, so they will lie on the graph. So let me just plot these. I'll plot 0, 0. That's just the origin. Is everybody used to making a table like this? Let me plot 1, 1. And I'll also plot 2, 4. 2, 3, 4. So here's part of my picture. These these 3 points lie on this graph, right? This is y equals x squared. And also, let me go ahead and pick x equals -1 and x equals -2 because I want to see also what it looks like to the left. So let me do -1 and -2, and right, the function is y equals x squared, so I'm just squaring these values. Y equals -1 squared, that becomes positive 1, and y equals -2 squared, that becomes positive 4. So I will plot this ordered pair -1, 1. So 1 left, 1 up, and also this ordered pair -2, 4. 2, 3, 4. So I have two sides of my shape. And we've seen this before. I know for a fact this is a parabola, right? So we know quadratic functions graph parabolas. Right? It's this little U shape. Can't see. Is it just loading? Or is it blank? Yeah, give it a moment. It'll probably catch up. So, um, with that being said, if you recall back to slope-intercept formula of a line, right? This is just y equals mx plus b, right? That's just a line. We've graphed a trillion of these, right? So this would graph the line with y-intercept b and slope m, whatever that happens to be. Notice if I change b here, the y-intercept changes. So b is basically like how high or how low the line is. If you have a function and you're just adding a number on the outside, this is going to shift the function up and down. In fact, let me pull up Desmos really quick. I'm going to switch my screen to Desmos. One second. Let me restart Discord. It'll take 15 seconds. Thank you. Sometimes Discord gets kind of angry. Alright, so can we see Desmos here? So if I just have my line, like say y equals 2x plus 0, right? Slope to y-intercept 0. It's right there, right? I'm going to make this a variable just so I can add a slider, right? So currently it's 2x plus 1 because c is 1. And notice our y-intercept is right there. So as I change c, it's just changing the vertical position of this line. Do you see how that works? So this is the vertical shift. Whatever kind of function you have, if you're just adding a number on the outside at the end of the function, it becomes a vertical shift. So let's take another look at our parabola that we just graphed a minute ago. Right, this is what we found with the table. And so if I add c, and I have a slider for c now, it's just a vertical shift. Do you see how c is only a vertical shift? It's changing no other characteristics than where that vertex is hitting the y-axis. Okay, let's head back to the blackboard. So, if you have y equals x squared plus some number, this is the vertical shift. So it's like I have my normal parabola, it's just shifted c units. And if c is positive, it's shifted up. And if c is negative, it's shifted down. So I'll show an example of that. Consider y equals x squared plus 2. So if I have my graph, that means that my vertex will no longer be at 0, but instead it will be at 2. Can't see the screen. Can anybody see my screen? Okay, sweet, cool. So instead of the vertex being at 0, the vertex will be at 2. So we have the same shape before, it's just shifted up. And I'll show another one. So we just graphed that in this light purple color. And I'll show another one on the same graph. We can do, let's do y equals x squared minus 3. So then it will be shifted down 3 units. Cool. Okay. And so, going back to what we had earlier, by the way, sometimes we will call this the parent function. But that's not crucial to know. That's just a word you might hear in the future. So we've established that this is vertical shift. Okay. So, there's also something else. There's a way to shift this parabola horizontally as well. And I won't go into exactly how this works, but I mean, we showed that if you add a number on the outside, this is vertical shift. But so let me compare two graphs. This is one, and consider if I have, this is a horizontal shift when it's on the inside of the parentheses. This will cause horizontal shift. And so before, the vertical shift is on the outside, right? And if it's positive, it goes up. If it's negative, it goes down. Horizontal shift is backwards. So let me graph these two. I'll show you exactly what's happening. So I'll graph this first one in cyan. I'll underline it in cyan. So we just have our parent function x squared, just our normal parabola. And this guy will be shifted 1 to the right. And I'll graph this one in bluish. So this is shifted 1 to the right. So instead of the vertex being here, the vertex is going to be here. There we go, that looks better. So this will cause horizontal shift, and I'll show you on Desmos again. So now we have Desmos. So plus C on the outside is vertical shift, and if I put parentheses for what's being squared, and I add a plus C here, we see that this is horizontal shift as C changes. So notice, if C is positive, currently it's positive 4.2, it shifts to the left. Positive values shift it to the left. Negative values, C is currently negative 2.3, negative values shift it to the right. So it's kind of strange in that way. Okay, so interestingly, let's see. Whoops. Okay, we can see my blackboard now, right? Just making sure everything is good. Interestingly, both these horizontal and vertical shifts can happen independent of each other. And so let's see how that would look. So we're going to have something that we call vertex form. So y equals x minus h squared plus k. This is a parabola. And what is happening to this parabola is that it is being shifted k units up, k units of vertical shift, and h units, h units of horizontal shift. Notice h for horizontal, so that's convenient. H units of horizontal shift. And for this parabola specified by whatever equation we're looking at, the vertex is located at, and this is why it's called vertex form, because it tells you where the vertex is. The vertex is located at h, comma, k. Notice this is minus h, but it's still turned into h, and this is plus k, so it's still turned into k. So let's just look at this for a moment. So let's apply this. So say we are given something to find the vertex. And our equation is y equals x minus 3 squared plus 1. So this is in the form x minus h squared plus k, and the vertex will be at h comma k. So I'm looking at this number, minus h. This is minus 3, so what's h? H is 3. It's shifted 3 units, and then k is 1. So here's my vertex here. Wish I had some more room here. Let's try another one. I'll just write it below. So consider y equals x plus 6 squared minus 2. So notice, in vertex form this is normally x minus h, but this is plus. So when it's minus h, that means that h is positive. If it's plus, that means that h is negative, so it has to be negative 6. In other words, whatever I see here, I'm always flipping the sign. Notice how negative 3 became positive 3, and positive 6 became negative 6. And this is minus 2. This sign I always keep. Notice how negative 2 became negative 2 and positive 1 became positive 1. So, in other words, we take this, flip it, and keep that. Okay, let's try some of these. I'll give you a couple to try. Please find the vertex. So let's see, y equals x minus 3 squared plus 7, y equals x plus 5 squared minus 10, also y equals x minus 2 squared minus 4. That's fine. And for reference, vertex form, y equals x minus h squared plus k. The vertex lies at h comma k. In fact, let me do that in a different color. So go ahead and take a moment to attempt these. Vertex form is very convenient, very helpful. Okay, let's graph some of these, actually, as long as we're comfortable with getting these vertices. Let me clear this page. Today is the 7th. We're actually not too far from being done with the school year, y'all. It's kind of crazy to think about. Okay, so let's see. So going back, basically we're just going to be graphing parabolas, right? And this is this U shape. We're not going to, this isn't an exact science yet. I'm not too worried about it being perfectly proportioned or anything. So all we need to do, my dog's trying to unplug my mic. goodness. Okay, so all we need to do is find the location of the vertex and then draw our U. So imagine that this parabola is floating in space. We're just going to plop it down somewhere on the graph wherever it belongs, if that makes sense. Okay, so let's try some of these. Let's see. I will show you how it's done. Let's maybe x plus 3 squared plus 1. So the vertex will be, I'll do it here in cyan. Take this first number, flip it, -3, +1. So let's graph some axes. And on the homework tonight, we're going to have graph paper. Well, not graph paper, but graphs on the homework. And so thankfully you won't have to draw your axis every time. And so we need to put a vertex at -3, 1. So I go 3 units to the left and 1 unit up. Here's my vertex, and I will go ahead and graph it. It's just going to be a parabola with vertex at this point. So where the parabola would normally be here, it's been shifted 3 units left and 1 unit up. Let's try another one. In fact, maybe I'll do it on a different graph actually. So let's do y equals x minus 4 squared minus 2. So the vertex here will be +4, -2. So let's graph our parabola. So I'll go 4 units to the right, 2 units down. Here's my vertex, and this is my parabola here. Any questions about this? Okay, let's -4. So I got 2 units to the left, 4 units down, and I will graph it in green, lime green. So my vertex is here, and the parabola opens up. This other one, the vertex is +3, -5. So I will go to 3, -5. Sorry, whoops. Shouldn't they be +5? +5. Thank you. 1, 2, 3, 4, 5. I'll do this one in red. Do it in a light red. This kind of salmon-ish color. Alright, any questions about these two oh my goodness. Any questions about these two parabolas? Also, make sure that they don't look like this, right? That's an absolute value graph. Make sure it's at least a little curvy. We like them curvy. Okay, let's see. We have a little more left to do, so go ahead and take like a 1 or 2 minute break. Be back here at 9:02. Did you like that? We like them curvy. That's not inappropriate, is it? Are most of us back? Can you let me... Oh, I'm muted. Are most of us back? If you are present, please let me know. All right, sounds good. There's one, so we talked about two transformations, horizontal and vertical shifts. There's one last kind of transformation. So, um, once again, comparing just to the parent parabola, y equals x squared. We know what this looks like, right? No problem. Maybe I should draw it in orange like I had. Cool. So, there's also, imagine if there were a negative out front. So we have negative x squared. Going back to your lines from this year and last year and the year before, that would just mean that it has negative slope, right? But it's not quite the same idea here. Instead, what's going to happen is that instead of opening up, it's going to open down. So it just means it opens down. So there are three kinds of transformations here. Horizontal, vertical shift, and then whether it opens up or down. Okay, let me show you one of these. I will graph y equals negative quantity x plus 3 squared plus 1. So the vertex will be negative 3 comma positive 1, and it will open down, right? So we need to be careful to remember that. Negative 3 comma positive 1. Graph my vertex, and then I'll make my U-shaped parabola, but it doesn't open up, it opens down. Why don't you also try one? I will give you negative quantity x minus 5 squared minus 2. So go ahead and graph this. Are we still working? Have we finished? You guys are doing awesome, by the way. I know these times are very strange for education. If you're still working, please let me know. Okay, let's go ahead and take a look. So the vertex would be positive 5, comma, negative 2. I'm just going to graph it on this same graph. So go out to positive 5, 1, 2, 3, 4, 5, negative 2, 1, 2. Here's my vertex. And it will open down, right? That's the negative out front. And when you're doing the homework, if you ever forget what these look like, Desmos is your friend. It will remind you what they look like, and furthermore, what each number does. So it's always helpful to use Desmos to consult your work, not to do your work, right? Um, let's see. I think I'm going to leave y'all with that. There was something else I was going to do, but I don't think we really have enough time. So I haven't posted the worksheet on the portal yet, but I will here in a moment. And I will have y'all do the first half of it. With that being said, have a beautiful day. I think the weather's looking pretty nice out there. Alright, peace, y'all.